Hello everyone. In this video lecture, I am going to discuss about the interfacing of gas sensor with the Arduino board. Okay, basically gas sensor is used to detect certain kind of gases like a methane, toxic gases, LPG gas, nitrogen gas. Okay, so how it actually works, how it can be connected with the Arduino board that I am going to discuss in this video lecture. So let us start with the topic that I am going to discuss in this video lecture. So first one is a hardware and software requirement. If you want to interface a gas sensor with the Arduino board, I am going to use the Arduino Uno board. Okay, you can also use the Arduino Nano board. The second one is a gas sensor working principle. It is very important to know how the sensor work, different kind of sensor work. So what is the working principle of gas sensor? Gas sensor connection with the Arduino board. And the next one is a Arduino code and Proteus simulation. What is the code? How Arduino code is written for gas sensor interfacing and Proteus simulation. And the final one is the hardware implementation video. I have done the interfacing of gas sensor MQ2 gas sensor with the Arduino board, and that video I have taken and added in this video. Okay, so let us start with the first hardware and software requirement. So first one is Arduino Uno board. You can also use the Nano one. Gas sensor, different kind of gas sensor are available, MQ2, MQ4, but I am using MQ2 gas sensor. The third one is the LEDs, which is used to indicate that gas or smoke has been detected. Then jumper wire for connection of LEDs, gas sensor with the Arduino board. Then USB cable for connection of Arduino Uno board with the laptop or PC, or for given the supply to the Arduino board for uploading the program in the Arduino board. Then software requirement. So we require Arduino IDE for writing the Arduino code, and if we want to check whether our program will run on hardware or not, for that I am using the Proteus simulation. Okay, next one is the MQ2 gas sensor. Okay, so what is the MQ2 gas sensor? So basically MQ2 is a type of gas sensor. As I mentioned that MQ2, MQ4, there are different kind of gas sensor available which measure the different kind of gases, which detect the different kind of gases. Okay, basically MQ2 gas sensor is used to detect the presence of propane gas, LPG gas, hydrogen gas. It is also used to detect some toxic gases like methane and other combustible steam. It is also used to detect the smoke also. Basically, these kind of gas sensors are used for the safety purpose in different places. Okay, sensor is sensitive to flammable gases and smoke also, as I mentioned. Okay, now this is a construction of MQ2 gas sensor. Okay, basically it consists of mesh. You can see the sensor is basically enclosed two layers of fine stainless steel mesh. These are nothing but the mesh, and it is also known as the anti-explosion network. What is the purpose of that? It ensures that heater element inside this, basically the sensing element inside this, will not cause any explosion. Okay, as we are sensing the flammable gases. Okay, it also provides the protection for the sensor and filter out suspended particle. It allows only the gaseous element to pass through, which are going to be detected. Okay, the mesh is bound to the rest of the body via copper ring. You can see here. It is connected with the body by means of this clamp ring. And this is the internal structure. What is there inside this? So as you can see, there are 6 leads available, and these are nothing but the sensing element. So let us see how that sensing element works. Okay, what is the construction of this sensing element? As I mentioned, there are 6 leads. Okay, out of these 6 leads, 2 leads are responsible for hitting the sensing element. Okay, you can see these 2 leads are responsible for hitting the sensing element, and those are connected to nickel chromium coil. Okay, which is known as a conducting alloy. Okay, remaining 4 leads, that is AB leads, okay, are responsible for getting the output signal, and those are connected by means of platinum wires. Okay, these wires are connected to the body of the sensing elements, and it gives the indication, it conveys small changes in the current passes through the sensing element. Okay, now how sensing element work? Okay, let us understand this. So this is the sensing element. Okay, this is in kind of tabular form. Okay, and it is made up of 2 material: aluminum oxide, base ceramic. Okay, and on that aluminum oxide base ceramic, there is a coating of tin dioxide. Okay, tin dioxide is most important material. Okay, which is being sensitive toward the combustible gases. Okay, so tin dioxide is sensitive to the different kind of gases, and this is a structure, internal structure. You can see one coil is there. Okay, and that is a nothing but the nickel chromium heating coil. Okay, on that aluminum dioxide layer is there, and on that coating of tin dioxide is there. Okay, and these 4 leads of platinum wires. Nickel chromium coil and aluminum oxide base ceramic forms the heating system, while platinum wires and tin dioxide layer will form the sensing system. Now let us see how gas sensor work. What is the working principle? So one GIF is used, which is used to understand how it works. So basically, tin dioxide layer is there, as I mentioned, which is heated by means of that coil at high temperature, and oxygen is absorbed. These blue color oxygens are absorbed on the surface, and that will attract the donor electron. Okay, so if donor electron will be attracted, you can see now the donor electrons are attracted with the oxygen. Okay, so there is no flow of electron. Okay, so this prevents the current flow. Now what happens if some reducing gases are present, toxic gases are present, the surface density of the absorbed oxygen decreases. Okay, because what, this black color, these are the toxic gases element which react with the hydrogen oxygen atoms. Okay, and then electrons are released. Now electron will be released. Okay, you can see now electrons are released and there is a flow of current, and flow of current is there, so we can see how we will get some output from the sensor and we can say that something has been detected. Now let us see the pin configuration. So these are the pin configuration of gas sensor. Okay, the one pin is VCC and one pin is for ground, and there are two pins, digital and analog pin. Okay, see in analog what we have to do, if you are using the analog pin, you have to set some threshold value in the program. Okay, if that analog output increases beyond that value, okay, then and then you can give some alarm signal. And digital only you will get something has been detected or not detected. Okay, so these are the four pin VCC, ground, that is for power and ground respectively. Digital pin is there, it produces the digital signal. Okay, and analog pin is there, it generates the signal proportional to the intensity of methane or any toxic gases. Now this is the MQ2 gas sensor connection with the Arduino board. Here I have used two LEDs, green and red LEDs. Okay, so green LED is under normal condition, nothing has been detected. But if something will be detected, okay, so red LED will be turned on. Okay, and these two lines, red color and black color lines, are for ground, are for power supply and ground, and this green color line is connected with the analog one. In actual hardware implementation, I have used the analog pin. Okay, so this is the connection of MQ2 gas sensor with the Arduino board. Now let us see the Proteus simulation. So in Proteus, what I have used the MQ2 gas sensor library. Okay, if it is not available in your Proteus, you have to paste that library in the library folder of the lab center, which is in the C drive. Okay, then digital toggle is there. Okay, which is used to give some toggle that's in virtual environment we cannot provide the gas. Okay, so this is nothing but the we are giving some input that something has been detected. Okay, LCD is used to display whether gas is detected or not. Okay, there are two LEDs which are connected with the 12 number and 13 number pin. This is a terminal I have used. I have not made direct connection. Okay, if I will make the direct connection, number of wires will increase. Ultimately, Proteus will take more time. So that's why I am using this kind of terminals. Okay, which is connected with the LEDs are connected with the 12 number pin and 13 number pin. Okay, and here in gas sensor you can see VCC is connected with 5 volt, ground is connected with the ground, and in here digital output will be available, not analog output will be available. So that is connected with the 10 number pin. In actual implementation which I have done, I have used the analog one. Okay, so let us now let us move towards the first Arduino code for this, and we will see the Proteus simulation. So this is the code for interfacing the gas sensor with the Arduino. In the basically this code is for Proteus simulation, and for actual hardware implementation I have used a different code. Both code I will explain. Okay, first in as I mentioned, I have used the LCD, so we have to include this library. Basically, if we include this library, all the function related will be related to the LCD will be covered. Okay, then liquid crystal LCD. Okay, that sets the pin. Which pins are connected with which pins of Arduinos are connected with the pins of the LCD. Okay, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7 are connected with the data pins, and 2 and 3 pins are for RSN enable. Okay, how this work that I have already explained in my one of the video of LCD interfacing. You can see that. Okay, now 3 pins I have used. First one is for sensor, that is a MQ pin. Name given is a MQ pin, that is sensor is connected with the 10 number pin. Then red LED is connected with the 12 number pin, and green LED is connected with the 13 number pin. Okay, now void setup. In void setup, as usual, what we have to do, we have to define which pin is the input pin and which pin is output pin. So MQ pin, that is a sensor pin, which is an input pin, and pin mode red LED and pin mode green LED, both are output pins. So I have written output over here. Now, as I am using the LCD, the first, before we write any function related to the LCD, first we have to use this function, that is LCD.begin in bracket 16 comma 2. That means what? I have selected the LCD which is having 16 column and 2 rows. Then LCD dot set cursor. Okay, so what it will do? So 5 comma 0, that means what? Fifth column and 0 row. So 0 row. So whatever text I am going to display, that will start from fifth column and 0 row. And LCD.print, so gas will be detected. Gas will be displayed on the LCD. Now, again I have used this LCD.setCursor 3 comma 1. What it will do? It will take the second row, that is 1. Okay, and column will be third one. Okay, and from that position I will display the detector. Okay, and serial.begin in bracket 9600, that is for if you want to print something on a serial monitor, that you can use this command. Okay, now void loop, where we are writing our main program. Okay, so I have defined one in gas value. Okay, that is an integer where I have defined, in which I am storing the status of the MQ pin. Okay, that is connected to the 10 number pin. So digital read, that will see the status of 10 number pin, whether it is high or low. Okay, now there are conditional loop. If that gas value is high, okay, so digital write red LED pin will be high, digital write green LED pin will be low. Okay, and on what will be displayed on the LCD? So LCD set cursor 6 comma 0, that is a 6 column and 0 row. What will be displayed? Gas will be displayed, and again LCD dot set cursor 3 comma 1. What will be displayed over there? Detected will be displayed. And then I have given the delay of 2 seconds, and LCD dot clear, so it will clear everything. Then delay again of 200 milliseconds. If if the status of this pin is low, so the program will go in the else loop. Okay, LCD dot clear, everything will be clear, and digital write red LED pin will be low, and digital write green LED pin will be high. That means normal condition. Okay, that loop is completed, and again delay is given of 100 milliseconds. Now this is the code for gas interfacing, gas sensor interfacing with the Arduino. Now what, as usual, we have to do? We have to compile this code. Okay, here you can see compiling the sketch. Okay, if this code is successfully compiled, we have to find the hex file in the console window. Okay, over here you can find the hex file. You can see this is the hex file. The hex file you have to copy and paste in the Arduino board of Proteus. Okay, so I have already copied. Okay, now moving towards the Proteus part. So this is the design template of Proteus. You can see the different connection, as I have already explained. So I have taken the MQ2 gas sensor, LCD, two LEDs are there, for green for normal condition, red for if some smoke or gas is detected. This is Arduino board. Okay, you have to double click over here and you have to paste that hex file over here, which I already done. Okay, now I am running this code. So you can see now LCD is turned on and gas detector is displayed. You can see now LED, green LED is there. Okay, that is a normal condition. Now if I make this toggle, digital toggle 1, you can say now the digital toggle is 1. So here as gas is detected, is printed, and red LED is turned on. Okay, so this program is running perfectly on simulation. Now we can implement this program on the hardware. Now again toggle is 0 and you can see green LED is turned on. Okay, so simulation is working perfectly. Now let us see the second code which I have used for actual hardware implementation. So here I have used the analog pin, not digital pin. Okay, two LEDs are connected with 12 number and 13 number pin, and name given is red LED and green LED. Okay, these are integer. And the A4 pin I have used, the output of the gas sensor, analog output of the gas sensor is connected with the A4 pin of the Arduino. Okay, now I have defined some variable, that is sensor trace, and that value I have kept 120. Okay, now void setup, in void setup red LED and green LED are considered to be the output pin, that is a 12 and 13 number pin, and smoke A0, that is a 14 A4 pin, analog pin, which is considered as an input pin. Now I am going to display everything on the serial monitor, so I am using serial.begin 9600, that is a boot rate. Now in the void loop, the main program will run. So integer analog sensor, that is a variable I have defined, is equal to analog read. In the previous code I have used the digital read. Here I have used the analog read in bracket smoke A0. That is it will read the value of A4 pin. Okay. If and it will display serial.print pin A0 on the serial monitor. And the next one is the serial.print ln, that is a bracket in bracket analog sensor. So value of that smoke A0. Okay, if that value is greater than the threshold value which we have defined, that is 120, then red LED will turn on and green LED will become low. Digital write function I have used. Else, there is a if and else is the conditional loop. Else, digital write in bracket red LED comma low. So digital write, what it will do? It will make red LED, that is a which pin, 12 number pin low, and green LED pin will be high. Okay, if that value is below 120 and that loop is completed and delay of 100 milliseconds is given. Okay, so now first let us see the application of gas sensor and then we will see the actual hardware implementation video. So these are the application of gas sensor. Basically, it is used in kitchen to detect the different kind of gases like natural gas, LPG gas, city gas. In high building, it is used to detect the fire. For detecting the harmful gases in the industry, it is also used in mines, home safety, and detection of harmful gases in the mines. It can be also used. Okay, now see the actual hardware implementation. So here first you can see the different kind of components required. Arduino Uno board, then USB cable, and this is the gas sensor. Okay, let us have the closed loop of the gas sensor. You can see the 4 pins are there and 2 LEDs are there, basically for indication, breadboard and jumper wire. And this is the connection of gas sensor module and LEDs with the Arduino board. Okay, you can see how connection is being done. I have used the E0 pin, that is an analog pin. Initially the green LED is turned on. Okay, now let us see the value on the monitor. You can see pin A0 value which I have already displayed, that is a 77, which is less than 120. So green LED is turned on. Now what I will do, I will provide the smoke, okay, in the nearby region. Okay, so that value will increase. Now you can see LEDs, red LED is turned on and the value is now greater than 120. Okay, again if smoke is removed, so green LED will turn on, that value becomes low, that is less than 120. Okay, again smoke is provided externally, so red LED is turned on and you can see the value is 150, 130, which is more than 120. So in this video lecture, I have discussed the gas sensor interfacing with the Arduino board, how gas sensor work, Proteus simulation of gas sensor interfacing with the Arduino board. Hope you enjoyed the video. See you soon in the next video. Thank you for watching.